Alright, so this video is a continuation of 5.3, which is really differential equations, and that's an equation that has a derivative in it. So here's an example we didn't get to that was in your notes. Depending on whether I've reorganized and remade these videos, as of right now, this one was a little bit out of order. We had to skip it in the interest of time. So hopefully we can keep this video nice and short, get through this example, and you're probably getting some pretty good skills at this point. So let's talk a little bit about this. So the equation of the curve, I guess, is y equals, right? That's what we want to know. It has to pass through the point, so this here is my initial condition. Okay, just to talk about vocab, that's my initial condition. It's passing through the point and it has a slope of, well that's dy dx, that's, right, that's definitely dy dx. So let me make that a different color, because I already used red. So I guess what's happening is I have dy dx given to me as y over x squared, and I could probably start working on that now. What I could do is I could divide by y, I'd have dy over y equals, and now I'd have 1 over x squared dx if I separate it out completely. And I can actually integrate that and just kind of roll with it. So if we integrate this, this is ln of the absolute value of y equals, this is x, this is actually x to the negative 2. So that's going to be, let's see, add 1 to that power and divide by that power plus a arbitrary constant. So that's kind of where we're at right now. And I could probably simplify this a little bit. Let's call it ln of the absolute value of y equals negative 1 over x plus c, and that's where we are. So now in comes the green condition, which is the point 1 comma 3. And the cool thing is that in that case we have ln of the absolute value of y. Well, this absolute value isn't useful anymore because we see that our y is positive. We see that we have a positive y. So we don't really need to use the absolute value. We can just write ln of 3 equals. And now this is actually just negative 1 plus c when you plug in that 1 for x. And I guess you have your c is equal to ln of 3 minus, or actually plus 1. And that's there. So that should be our constant, so I will take a second to check and make sure we are on it before we move on. Okay, so it doesn't seem like there's anything wrong with what I've done. I just have to be aware of what I've done. So what I did was I never solved this for y. So I now have ln of y, right, equals negative 1 over x plus ln of 3 plus 1. That's kind of where I'm at. And I still need to kind of get y by itself. So to do that, I'm going to need to exponentiate both sides. So I'm going to have y equals e to the, and it's going to be e to all of this stuff, right? So it's going to be e to the negative 1 over x times e to the ln of 3, if you use the reverse property there, times e to the 1. So how can I simplify this? So it's like kind of like, do you want to have the difficulty of solving it now, or do you want to have the difficulty of solving it later? Either way, you're going to have to do a lot of work. I'm going to cancel e to the ln to make that just 3. So it looks like y is equal to 3. And I will actually take these and use the addition property. So I will make it now e to the, well, 1 is x over x, so x minus 1 over x. I think that's what I can say. And I think we should be in a good place with that. And now I'm going to go confirm again. Yep, so that's the solution. So a couple of things that are weird about it are the absolute value, understanding that. Look at your points, and that kind of helps you to understand what's happening with the absolute value. The other thing that the book did is they took this right here and they solved for y first before they went to this. So they took this and solved it, and then they went to this afterwards. But I kind of did it in the opposite order. I solved it out, got my constant, and then I solve for y after. So you can do either. I personally like to solve for my constant after. I mean, I personally like to solve for y after. I find it to be a little bit easier. Okay, so you already tried this one, I think, yesterday. And now we're on to this problem. So what I want you to do is, if your packet has this, great. Go ahead and follow along with it. If it doesn't, then just flip it over, because I think that with this year's class, we at least have the back of the packet is blank. So flip it over, and we're going to try this differential equation. First thing we're going to do is just a quick review of slope fields, because they're going to obviously be intertwined with this a lot. So if we look at like what they gave us for this diagram here, let's see if I can make this a little smaller for you so it fits better. If you look at what they kind of gave you, what I would do is just simply, it's 6 points, right? And I would just make an XY chart for those 6 points and figure out what the slope is at each of those, so dy dx. So it looks like there's x equals 1, and there's 1, 2, 3 of those. And then there's x equals 0, and there's 3 of those. So it looks like we have 1, 1, 1, 2, 1, -1. And then we have 0, 1, 0, 2, and 0, -1. So all we need to really do is take all of these and plug it into this to find the slope. So the slope is going to be, in this case, 2 times 1, 2x, minus 1. So it's just going to be 1. That's what your slope's going to be there. Let's keep going. 2 times x minus, so that's 2 minus 2, so this is the slope of 0. 1, I'm just plugging into the red circle. 1 times 2, that's 2 plus 1 in this case, it looks like, so that's a 3. Let's see what I've got here. I have 0 minus 1, so just -1. I have 0 minus 2, and now I have 1 here. So I'm just going to start plotting those slopes. So at 1, 1, I'm going to make a slope of 1, so that looks like this. At 1, 2, I have a slope of 0, so that's pretty straightforward. At 0, -1, I know I have a slope of 1, so I'm going to go ahead and do that one right now. And then let's do our -1 slope. So we did this one, we did this one, we did this one. Let's do our -1 slope. 0, 1. That should have a slope of -1, so we'll just go like this. Oops, sorry, that's the wrong check mark. So now we got just a couple more. So all we have to do is basically make these slopes steeper because they are of 2 and 3. So 0, 2, 0, is a slope of -2. So I just need to make it a little steeper than that other one. So just kind of like that. Now that's done. And 1, -1 has a slope of +3. So all I need to do is make it a little steeper than the 2. So I need to make it like this, maybe. Okay. And if we're not like loving it, we can make this just a little less steep, just to make it a little more clear that it's not quite as steep. Okay. And if you're scared of that, you can make your you can make these ones even flatter. You know, you can make all those flatter. So I was dumb because I didn't kind of memorize what I was doing, but okay. 0, 1. Now you can kind of see it's a little bit more clear what's going on here. 0, -1. Okay, cool. So that's what our slope field would look like. Let's just verify that that's looking good. Yes, it is. Okay, so that's just a quick review of slope fields. Didn't want to spend too much time on that. I do want to spend some time talking about the next couple problems. So let's see where we're at with time. Okay, so we're going to skip around a little bit. I mean, these are great problems all in all. But what's going to happen is we're just going to need to go ahead and solve this one. It's the most important. It's just solving and finding a particular solution. So let's go there. So this part says to find the particular solution. When they say y equals f of x, I want to make this pretty clear. They want you to get y alone. And this is the particular or the exact, right? It's the same thing. And they give you initial condition, so this is our point, which is 2, 3. So basically that's what's happening. And then we'll answer that other question after, but let's just go ahead and solve. So we're going to need to, let's see, separate out, right? Separate out the 2. So what am I going to do? I guess what I would do is, take a minute here. Okay, interesting. They don't really want you to find the particular solution. I was jumping right on finding that, but if you look at it, the question is really, does the graph have a relative max, a relative min, or neither at x equals 2? So I guess what I would do is I would just look at x equals 2, right? And I would see if it passes this good old line test. I would just go with dy dx, or y prime if you like, and I'll plug in some numbers. So I'd plug in perhaps I'd plug in 1 and 3, and I plug in 2 and see what happens. So let's just plug that into the derivative. So they're not really helping us too much, but what they do say is that if x, there's this point xy of 2 comma 3. So I guess the only one we can really use here on this derivative test is we can only use this point. We can't really figure anything out about this. We can't really figure anything out about this. So this is going to take us down a different road in a second, but let's go ahead and plug the 2 in. So when we plug the 2 in for x, we get 4 minus, we know when x is 2 that y is 3, so it's going to be 4 minus 3. So this is going to have a slope of 1 here. So that's the interesting thing, because what that's saying is that it doesn't have either because it doesn't have a 0 slope there. So this graph is like going up until this x value of 2 where it has a slope of 1, and then maybe it has a max or something, but it's not a max here because this slope is not equal to 0. So this does not equal 0. And this is a little different than what I was looking for, but it's a pretty good question anyhow. So this is the second derivative. Good stuff, but definitely more of a review thing on part B. And then here, they're asking you to find the values of constants for which this is a solution to the differential equation. And if we have time, we'll go through that. But I would say we are cutting it kind of close. So we'll end it there. Keep it pretty simple for today. Yeah, so that's it. See you, and talk to you soon.